Hi guys, welcome back to my channel. Tonight, we want to take a look at 2024 Waec practical titration. So this video basically on what? Alternative to practical. Is that clear now? But I want you guys to take note of one thing. Sequent to the Waec procedure or to what provided in each schools for the upcoming examination, which is stipulated to hold next week, is based on redox reaction. And what do you understand by that redox reaction? For every redox reaction, they deals mainly with reduction and oxidation. Is that clear now? So guys, we are given two compounds, permanganate and iron 2 sulfate. So KMNO4, this is pink, and iron 2 sulfate, this is green. You know, I dropped a video last week about qualitative analysis to some compound and their inference, their observation and their what? Their inference. So now, want to take a look at this now. Don't forget I said redox reaction. We are dealing with reduction, and we are also dealing with what? Oxidation. Is that clear now? So for every redox reaction, they undergo what we call oxidation reduction. And don't forget that for every reduction, when it's come to redox, oxidation is gain, while oxidation is loss, while reduction is what? Gain. Again, oxidation is loss, while reduction is what? Gain. So guys, back to this now. Looking at what you have on the board, this is likely correction. I'm not saying this is a question you will come across in your Waec examination, but likely what? Correction. The first one goes thus: concentration of B in mole per dm cube. Note one thing to those science students out there: if you are to prepare or you are to carry out the titration, what will be in your burette is KMNO4, and there is a traces of sulfuric acid here, 2 mole of what? Sulfuric acid in that. So the main reason why I dropped this last question, or the fourth question, that suggests a reason for adding dilute sulfuric acid to the manganate solution before titration. Sulfuric acid has effects because this KMNO4 is served as indicator already. So what is now the effect of the sulfuric acid? So I'll be explaining that. But then for this iron 2 sulfate, which is what? Green, with this will be in our conical flask, which is said A is a solution of potassium tetraoxomanganate 7, which is the same thing as what? Potassium permanganate, which is this. And B is a solution of iron 2 sulfate, which is this, which is green. This will be in the conical flask, while this will be in the burette. Is that clear now? So now, for those teachers out there, this is the procedure. Put A into the burette, as I've said earlier before. That's the permanganate. Pipette 20 cm cube or 25 cm cube of B into a conical flask. In some school, we have the measuring cylinder. Some school make use of that as a pipette in place, so they want to improvise. And we have our normal pipettes that they can easily use. So to the meniscus, we have the 25 cm cube or 20 cm cube. So to those teachers, they're taking the that. Repeat the titration to obtain a concordant titer values. Tabulate your results and calculate the average volume of A used. Note this: from your result and the information provided, first thing we have to calculate is that calculate the concentration of B in mole per dm cube. The same thing of A in mole per dm cube. Number of moles of iron 2 plus in the volume of B pipetted. Then this suggests a reason why we are adding dilute sulfuric acid to the permanganate solution before titration. And the last one is give reasons why dilute HCl and nitric acid, which is HNO3, are not suitable for use during the reduction. So guys, I'll be showing you guys more of the alternative way at which you can easily get your likely question and the solution. So guys, now let's take a look at how we can have our table of value. And based on the value you have on the board, this is the research I did myself. And to those students out there, and to those science students out there who are giving their students a titer value, please and please ensure that the titer value you are giving your students is the one you have done as your own pre-practical, and you are sure of the value you are giving to your students. Don't give your students a different value you use on your pre-practical, then on the day of their examination you are giving them another value entirely. That is going to cause an error, because if you are to impute your value, or that's your report, you need to put in the correct value you are sure of. And note one thing, that not all schools will have the same titer value. So let's go back to what we have on the board. We have breath reading. My rough titer I did during the process. And note one thing, if you are doing any redox titration, the KMNO4 again is acting more as indicator. And why is sulfuric acid being introduced there? The reason is because sulfuric acid is stable toward oxidation. Is that clear now? So guys, back to this now. We have the volume of KMNO4 used. So we're going to look for the average titer value. So with that, you can say we have average titer value. We have the first titer plus the second titer divided by 2. Are you getting that now? So what is our first titer? Note one thing, some students always make a mistake of adding both the rough titer, the first titer and the second titer value together. No, it's wrong. You only pick the first titer value and the second titer value. If prompt you have the third titer value, you are going to add the 3 together by dividing with what? 3. Don't forget, I told you guys that this particular video is telling you the likely corrections and alternative to the upcoming Waec examination. So with this now, I can say that I have 20.70 plus 23.00 divided by 2. So with what we have here, you can say that I have, you can see 0.70 20.70 plus 23. We have 43 cm cube. Please don't forget your cm cube here. Divided by 2. You can see we have 21.85. Is that clear now? So now, by adding 21.85, find the space of adding your cm cube. Please don't do the mistake of skipping anything you have there. So based on what we are asked or we are given to calculate, the first one goes thus. We have to look for the concentration of B in mole per dm cube. So before we go to that, let's take a look at the equation of the reaction. I have MnO4 negative plus 5Fe2 plus 8 hydrogen ion, Mn2 plus 4H2O plus 5Fa3 plus. This is oxidized from +2 to what? +3, and this is reduced from +7 to what? +2. So I will explain more on that. Why is it reduced from +7 to +2, and why is it oxidized from Fe2 plus to what? Fa3 plus. So back to this now. Concentration of B in mole per dm cube. So write that concentration of B in mole per dm cube. Is that clear now? So what you are going to do first is Note the formula to use here. So the formula goes as molar concentration equal, so we have this in mole per dmq. This is a unit for molar concentration. Some can call it molarity, it's still the same thing. So we have mass concentration divided by molar mass. The unit is what? Gram per mole. And note one thing, the B from the procedure I dropped earlier, for those of you that are going with me, that are flowing with me in this video, our B is iron 2 sulfate, and with that said molar mass of B, that's iron 2 sulfate, and it is given clearly that iron 2 sulfate is 152 gram per mole. Please take note of this. Exactly now, 152 per mole. So what is our mass concentration? From the question, we are given that we have, this is it, we have 2.75 gram of 500 cm cube. Initially, from the report given by the Waec, it is 5.5 gram per dm cube. So it means that if you are to prepare that, is that you divide it into 2. So when by doing that, when we have a 2 group, 2 point, but don't forget that Waec gave us what? To weigh 5.5 gram of that iron 2 sulfate. So telling you that if I have given you this in Waec, it can come in that form. But notice that the 2.75 given to you will be multiplied by 2 to give us the initial value given by the Waec, exactly, which is what? 5.5. So you can say that I have mass conc, we have 2.75 multiplied by 2, so we have what? 5.5 gram per dm cube. Now we have all the parameters. This is our mass conc, and this is our what? Mass concentration. Exactly now. So what we are trying to do here is that we are trying to look for the value of the molar concentration of B in mole per dm cube. So by doing that, you can say our molar concentration equal to, we have 5.5 gram per dm cube, all divided by what? 152 gram per what? Per mole. This cancel what? This. So you can say we have mole per dm cube for the units. So let's check for the value. We have 5.5 divided by 152. We have 0.036. Don't forget, 0.036 mole per what? dm cube. So take note of this, that our mass come in B mole per dm cube is what? 0.036. And note one thing, our B serve as the base. Concentration of B in mole per dm cube. So that serves as what? The base. Exactly now. So let's take a look at the second question. Please take note of what you have on the board. Take a screenshot of that. So we have number 2. Number 2. You can see this is number 2. Concentration of A in mole per dm cube. This. So concentration of A in mole per dm cube. So let's take a gradual step in solving this question too. It is not as difficult as you think it is. Are you science students out there, or are you what? A chemistry tutor? So take a look at this. You have Ca over Va, Cb, Vb equal to what? Na divided by what? Nb. So now, before you can do anything, we are looking for the concentration of A in mole per dm cube. So the concentration of A in mole per dm cube is what? Ca. So for you to have your final value or your answer now, looking at what you have on the board now, our number of mole of acid here is what? MnO4, which is this 1. Number of mole of base is what? 5. So you can say you have Ca unknown, Va average volume of acid used what? That's for our KMnO4, we have 21.85 cm cube. Our Cb is what? 0.036 mole per dm cube, what we calculate for the other time. And our Vb is the volume of the pipette used. If your school is using 20 cm cube, stick to that. But based on my research, I'm using what? 25 cm cube. So 25 cm cube. Then my Na is 1. Then my Nb is what? 5. Based on the equation you have on the board. So it's this now. It is very simple. Just cross multiply. That is it. So you have Ca, Va, Nb equals Cb, Vb, Na. Exactly now. So what's our Ca? We don't know it. Okay, Ca, what's our Va? 21.85 cm cube. But our Nb is 5. So equal to, what's our Cb? 0.036 mole per dm cube, multiplied by our Vb is 25 cm cube, multiplied by our Na is what? 1. So what you have here, add, multiply these two together, multiply what you have here together, then you divide. So with that, like I said, I have 21.85 multiplied by 5. So again, 21.85 multiplied by 5. So that will give us what? Multiply by 5. So we have 109.25 cm cube Ca equal 0.036 times 25 times 1. We have what? 0.9. Is that clear now? So let's take a look at what that will give us. So we can say we have 0.036 0.036 times 25. Okay. Zero point 0.036 multiplied by 25. So we have 0.9. So when you divide both sides by this cm cube, this cancel this, so we have 0.9.25 Ca. Don't forget the unit, so we point our 0.9 divided by 109 points divided by 109.25. So we have our value is 0.008. We have 2, but I will say the best answer you can have here is what? 0.008 mole per dm cube. So exactly now, you can see how easy it is to solve. Don't forget, I told you guys earlier that these are likely equation that you come across in your examination. Don't forget to subscribe to my channel and also share across the students who are preparing for the exam. So let's take a look at the last one, which states number of moles of Fe2 plus in the volume of what? B pipetted. So that's so in that case we can say number 3, number of moles of Fe2 plus in the volume of B pipetted. So class, for this is very simple. You can say N is equal to CV. So N equals to CB and what? VB. So what is our CB? Our CB initially, from what it calculates for, was what? 0.036 mole per dm cube. This mole per dm cube, don't forget your VB is what? 25 cm cube. But because of this mole per dm cube here, so we said 1 dm cube is equivalent to what? 1000 watts cm cube. So with that, I can say that I have 0.36 multiplied by 25 over 1000. So with that, punch our calculator. So 25 divided by 1000. So we have N equal to 0.036 multiplied by 0.025 multiplied by 0.036. Wow. So our value, so we have it in standard form too. So again 0.036. Okay, so 0.036 multiplied by 0.025. So we have it to be 0.009 mole, because we are looking for the mole of that. So before we move on, the last but not the least is, you can see, according to what I dropped on the board, I said suggest a reason for adding a dilute sulfuric acid to the permanganate solution before titration. The only reason is because sulfuric acid is stable toward oxidation. Again, sulfuric acid is stable toward oxidation. And 1803 are not suitable for use during the reduction. Note one thing I said earlier, that this MnO4 here is being reduced to what? Mn2 plus. And if MnO4 reacts with HCl, dilute HCl, they are not suitable because chlorine gas will be easily what? Evolve. And why is it that this HNO3 here is not also suitable? Is because to MnO4 is because HNO3 is a powerful oxidizing agent. So with that, they are not suitable to easily work or react with MnO4. So guys, I will easily put down what you need to know about this on the board. Don't forget to subscribe to my channel, like, share among your colleagues who are also a beneficiary of this 2024 Waec chemistry.